Hello, this is James Black, one of your instructors for EMEC 361. It's spring 2019 and I'm making a couple of videos for you to make it through your strain gauge load cell lab. This first video is about the equipment we'll be using. So the basis of it is this here. This could be used in multiple different ways. We're going to use it as a load cell. So in any case, it utilizes strain gauges to measure the strain, and that could be either if you're interested in a load, or this micrometer could be used for displacements, measuring displacements. We're going to use it for the loads, like I said. It has 4 strain gauges, so you have 2 on the top, and there are 2 matched underneath. So we're going to have 2 sets of banana clip jacks so each set will go with 1 strain gauge, either on the top or on the bottom. This one here is labeled top and bottom, and I checked that. Yours might be labeled, it might not be. Even if it is labeled, I'd recommend following those cables back to make sure the top is the top and the bottom is the bottom. And then the green ones, those are strain gauge it's just here on the base. You can see that down there. That would be the dummy gauge if you want to use that for temperature compensation, but only using a single strain gauge, as in a quarter bridge load cell. We're going to be doing the half bridge, so we're going to use 2 on the top and 2 on the bottom. Sorry, 1 on the top and 1 on the bottom. Because of that, it allows us to, like, even if you look down here, the connections, it's pretty fine wire. It's been soldered on. Many students use these every semester. Sometimes these break off and need to be resoldered. Using the half bridge, that allows us to only need 1 on the top, 1 on the bottom. We don't actually have to have all 4 work. I went through these and checked, and we have almost all stations have all 4 working. You just need to find, if you break off a wire, you need to use the other one. Just find 2 that work, and you'll be good to go. If we need to resolder some of those back on, we'll do it. But try to be careful with it so we don't break those off, and we can get you out of lab sooner. The dimensions of this are given in the lab handout. But just to make sure that it is the same thing, you should measure these when you get here. I'm talking about the thickness and the width and the length. All those things that you need to theoretically derive the sensitivity of this. So what we're going to do, we're going to do 2 parts of this. The first part, we're going to calibrate this. So we'll experimentally be determining the sensitivity. And then once we determine that sensitivity, we're going to, using LabVIEW, we're going to essentially calibrate our device so that when we apply a load on here, we get a readout from LabVIEW that is in pounds force. We'll do that. So with this weight system, you can hang this on the end. You'll do it for different increments, say maybe like 5 different increments. So some of these are labeled, and some of them are correct, and some of them are intended for a balance that is, has, it's times 2 the mass. So we do have a digital scale. You'll want to measure each of these just to make sure that you actually have the correct mass that it's labeled as, and it wasn't intended to be used in a device where you're getting times 2 the mass. So you'll measure, say, like 5 points. So you're going to get a known mass and a certain output. And because we're on planet Earth, that pound mass is going to translate to the equal pound force. And you can use that then to check the ratings of fly fishing tippet. That's going to be the second part. We're going to, I believe the lab handout tells you to test 9 different samples. It tells you to do 5 of one gauge, then 2 of 2 others. And I'd recommend that you use the lighter rated tippet for the test where you measure 5. So that's going to be the higher number. So 7x would be a good one to do your 5. And then for whatever's available, if it's 5x, you're going down, you do your other 2 tests. The reason for that is some of the heavier gauge stuff, the stuff with the higher load rating, it's possible you might bottom out with this. So use the lighter gauge stuff to get your best readings. Let's talk about some of the other equipment we're going to need. Since we're using the half bridge setup, we need a couple resistors. We can use these boxes for that. We're going to need a power supply, and it's important that you calculate the power supply output voltage so that the current going through your strain gauges does not exceed 25 milliamps. So that's a pretty simple calculation. Just use that, look at that side of the bridge, the Wheatstone bridge, do the calculation, the Ohm's law for the 2 resistances. Remember, strain gauges are resistances. So we know the resistances of those. That's given to you in the lab handout text. I'll tell you right now it's 350. And since we're going to want to do the half bridge, we're going to want to make sure that our resistors are set to 352. I believe it probably already is. Yeah, there's 300, there's 30, there's 20. So that one's 350, that one's 352. So we'll have a balanced bridge to begin with. We'll have a top strain gauge in tension, a bottom strain gauge in compression. That makes up our Wheatstone bridge. And we'll set up our LabVIEW to take care of a DC offset and have the sensitivity that we experimentally determine. Other equipment that we're going to need. So one, we're going to need we need a DAC so that we can control all this, get all of our data in and out to our LabVIEW code on the laptop. So obviously you'll need a laptop. And you're going to need a number of wires. You're going to need a couple to go from your power supply to your Wheatstone bridge. And you're going to need a couple to go from your Wheatstone bridge into your DAC. So most of us will be using a USB 6008 or 6009. There are plenty of those to go around. To get into your USB 6008, whatever it is, you want to get the banana clip cables that already have the banana plug cut off. So you can just get it in that way. Keep your circuits as simple as possible. The main thing here is don't be cutting off the heads and stripping back banana cables that still have their clips on them. This cable here is just my camera because the battery's dead. I think that is everything that you need for equipment. I will come back with another video in a minute to give you some tips on how to wire up this half bridge.